On this very episode, we're going to talk about understanding the number system properly. When you look at the number in mathematics, you will find out that numbers are just a symbol written to mark or carry meaning. If we are to define a number system, I will say that a number system is a way of representing numbers using digits and symbols. This sentence might look simple, but just look at it this way. If you have a symbol which is, let's say, number 5. Symbol in mathematics are used to represent numbers, show operations, describe relationships. For example, the number 5 represents 5 quantities. So this is just symbol without the meaning that it represents 5 quantities or 5 items. It will just be a symbol on its own. Same with number 10. Number 10 is a combination of two symbols, which are 1 and 0. 1/2 is also another symbol that uses a number and a division symbol. So this is just like writing 1 divided by 2, whereby this division sign, this is division sign, division. Also 0.5 also includes decimal points, which this is a decimal point, which on its own is a symbol. So we give meaning to these symbols in mathematics by attaching them to quantities, to operations, to things that they. Our normal math operations, addition, quality sign, greater than, all these and so on, are digits and symbols that we use, all written as signs to express numbers and their relationships. Let's find out what are digits. Digits are special type of symbols used to build numbers. In our number system, like base 10, the digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we have how many digits? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 digits in the number system from 0 to 9. Every number you can think of in math will comprise of a mixture of either just one or a mixture of two. A number system tells us which symbol we can use. When you think about 50, you know you are going to use 5 and 0 to get number 50. It also tells us how to combine it. Yes, just like we said, this is a combination of two digits, which are what? 5 and what? 0. And also what those combinations mean. So without this, you will notice we cannot count. We can't even measure, we can't compare, we can't calculate. So number system is very, very important. But knowing what number is and how to combine it and how to define it will help us to go a long way in understanding what number system is. Now, what are the types of numbers that we have? Numbers are organized into groups. Each group has its own behavior. The first type of number we're going to look at are what we call natural numbers. Okay, these are numbers that we use in counting. You know, when you want to count an item, let's say you have 5, you'll see the child counting 1, 2, 3, 4, 5 to represent the total number of apple given to him to count. Natural numbers are called counting numbers. They are used to count real objects. If you have 3 books, you will count them one after the other to get to 3, to know the total number of items that you have. In a classroom, we use natural numbers to count to know the total number of students that we have in a classroom. The second type of numbers that we'll look at are the whole numbers. Think of the whole numbers like this. They are natural numbers, but we include a particular number to it, and that is 0. Because sometimes, how do we now represent something that has nothing? An empty class. When you're asked to count something and you're not given anything, how do you represent that? How do you say that there is nothing remaining in the pot? A quantity that has finished. 0. That's what we're talking about. So whole numbers are natural numbers that include 0. 0 money, 0 apple. They represent nothing. That's the main reason why we have whole numbers, why we have 0. So 0 is used to represent nothing. So we can define whole numbers to be equal to natural numbers plus 0. So they include all the natural numbers you know from 1 to infinity and also 0. The next type of number that we'll look at are the integers. The concept of the integers are also, they include natural numbers, yes, whole numbers. Now, we'll now ask ourselves, how do we represent quantities that are in the negative? When temperature drops below 0 centigrade, how do we represent that? How do we represent loss of item? If we lose $50, how do we represent that? If we move in the opposite direction, how do we represent that? Integers helps us to what? Identify negative numbers. So it extends both directions on the number line. If we have a number line, the center point is always 0. When we go to the right, we have positive numbers 1, 2, which are natural numbers. It will go until it gets to infinity. When we go from 0 to the left, we decrease. We all have negative numbers, which will go from negative to negative infinity. Integers in natural numbers, both negative and positive, and also that is inclusion of natural numbers plus 0. So a number line is nothing. I know you may also want to know what is a number line, because we just made mention of that. This is a number line. Number line is just a straight line where numbers are placed at equal distance. Okay, so the right is positive numbers, the left we have negative numbers, and the center is 0. So it helps us to visualize numbers. Simple as that. The next type of numbers that we're going to look at, they are the rational numbers. When we talk about rational numbers, it is important that we understand what the word itself means. So it comes from the word ratio. And ratio is just a comparison of two numbers, usually written as in form of fraction, like this: A over B, where the number on top is the numerator. This is the fraction bar, and the number below is the denominator. So in the simple term, a rational number is any number we can write in form of a fraction. Also, in representing rational numbers A over B, note that A and are integers. That is, they are whole numbers, both positive or negative. Okay, it can be a whole number, it can be positive number, it can be a negative number. Also note that B not be equal to 0. You may want to ask, why must they be integers? If we use decimals inside our fraction, like 1.5, say 1.5 over 2.3, this wouldn't be an easy simple fraction to solve. Definition of a rational number requires it to be clean. It should be simple, easy to solve. The numerator, that's the number on top. Let's start from the denominator. The denominator represents this whole. Let's say this a whole. How many times is the whole divided into? If we have a piece of cake that is shared between 4 people, 1, 2, 3, 4. What our denominator is telling us, this piece of cake, how many equal parts is it divided into? In this instance, our answer is denominator here. Then the number on top, the numerator, will now ask us, out of that 4, let's assume that we are considering just one of it. How many parts are we considering? Some questions you will see shaded portion. So it is nothing else than counting the number that we are considering. In this case, we're just considering one portion. So our numerator will just be 1. If our denominator is 0, that means in the first instance, there is no fraction, there is no division. We just have an undefined quantity, okay? Meaning that we don't have need to even divide the cake. So 1 over 0 is not 1. Note, it is not 1. The reason why the denominator needs not to be 0 is that because in standard mathematics, arithmetic and algebra, dividing a non-zero number by 0 is truly undefined. Okay, so it is considered undefined because there is no logical consistent number that can satisfy that equation. Now the next number that we are going to look at, type of number that we are going to look at. So looking at this instance also, we are still explaining why this cannot be 0. Is because we cannot split this cake into 0 parts. Okay, we must split it into a defined number of parts so that it can be called a rational number and be placed in form of fraction. Examples of rational numbers: we have half, we also have negative 3 over 4, we also have 5. We want to ask, is this a fraction? Yes, because 5 can be written as 5 1. Any number that is divided by 1 will still give you that same number. Okay, in that case, all integers are rational numbers. Let me write it out. All integers are rational numbers. So take note of this, that all integers are rational numbers. You heard me say fraction. What are fraction, or what is a fraction? A fraction is nothing other than what? Part of a whole. A fraction is part of a whole. So this whole, this shaded portion, is still part of the same. Okay, so there are little pieces of parts that when we join together we get just example, similar example that we gave. These are what? Fraction. Okay, because they are part of the whole. The next type of number that we are going to look at, they are the irrational numbers. So irrational numbers are nothing other than numbers that cannot be written as fraction. The key properties that we should note about them is what? Decimals never ends. The decimal never repeats. Examples: we have root 2, we have pi. So irrational numbers are those numbers that cannot be written as a ratio of two integers. They are numbers that when they are written as decimals, they go on forever without ever settling into a repeating pattern. So what do we mean? Rational numbers, like we know, rational numbers are fractions in the form of, say, p over q. So they either end with numbers like that are in the form of 0.5, that's decimals, or they will end with repeating decimals like 0.3333. The 3 will go on till infinity. So that's what we know about rational numbers first. How do we handle numbers like root 2? How do we handle numbers like pi? So because they seem to defy these categories of ending in decimals like 0.5 or repeated decimals that goes on to infinity. So irrational numbers is a real number that cannot be expressed as a simple fraction of like p over q, where p and q are integers and q not equal to 0. The easiest way to identify an irrational number is to look at square roots. When you take square roots of a number that is not a perfect square, like root of 2, root of 3, square root of 5, square root of 7, and so on, the result is always going to be irrational. Why? Because there is no whole number or simple fraction that, when multiplied by itself, gives exactly 2 in the case of square root of 2. Okay, so when we look at pi, you will notice that we write it in form of 3.14, let's say 142, or as 22 over 7. So these are just nicknames that we use to represent pi, but they are just approximations that make our calculation easy. But in reality, pi starts from, let's say, starts really from 3.1415965, and it goes on and continues forever to infinity. So no matter how far you calculate, you will never find a sequence of numbers that starts repeating like a rational number, because it never repeats and it never ends. It is irrational. So I'll take my time to explain this rational number as well, so that you will understand it very, very well. When you have square root of 2, again, when you try to find a number that multiplied by itself that is equal to 2, let's say 1 times 1 is 1, that's too small. 2 times 2 is 4, it is too big. Even if you try decimal, let's say 1.4 times 1.4, you will get 1.96. It's still not close. If you multiply 1.41 times 1.41, you will get 1.9881. You see that what? You can keep adding decimals forever, getting closer and closer, but we'll never get to hit exactly 2. So the actual value will be like the root of 2 will give you Let's say 1.1441356. It will continue going till infinity. Don't assume that every square root is irrational. Let's take an example. Root of 9. It might look like an irrational number because it has a root symbol, but root of 9 is actually 3. This is because 3 can be written as 3 or 1, which is rational, okay? Always check if the number inside the roots or inside is a perfect square first. So 9 is a perfect square. So 9 is a perfect square because it has a number 3 that when you multiply it by itself, it will give you 9. That means square root of 9 will always give you 3. The other type of number that we are going to look at are the real numbers. This should be F. The other type of number we are going to look at, so they are the real numbers. So we have discussed all the numbers. Now, what are real numbers? So real numbers is a total. It combines all these type of numbers that we've talked about, be it rational numbers, be it real numbers, be it whole numbers, be it counting numbers, be it whatever number you can think of. They are all real numbers, both rational and irrational numbers. So because we know that irrational numbers, like we discussed, are numbers that cannot be written as a simple fraction, while rational numbers are numbers that we can write as what? A simple fraction, a over b. Real number is a complete number line. It comprises of all the numbers from 1 to infinity on the number line, and from -1 to negative infinity. So real numbers is any number that can be found on a continuous infinite number line. It comprises of fractions, integers, whether terminating or repeating decimals, any form of decimal, and all irrational numbers. That is numbers that never end and will never repeat. So essentially, if a number isn't imaginary, let's say I or to root -1, if it is not imaginary, that will make that number to be a real number, okay? Any number that is a rational number, that is numbers that we can write as fraction. Any number that is an integer, that is any number that is an integer that is from negative infinity to 0 to positive infinity. Any number that is a fraction, any number that is a decimal, that is a root, irrational number. So real numbers comprises of natural numbers. Let me write it out. Real numbers comprises of what? Natural numbers, whole numbers, integers, rational numbers, real numbers. So why we put rational numbers and irrational numbers? So real numbers comprises of natural numbers, which are what? Our counting numbers. Comprises of also whole numbers, which are 0 plus all counting numbers. That's 0, 1 to infinity. Integers we know are what? Whole numbers and their negatives. Whole numbers and their negatives. So from negative infinity to 0 to positive infinity. So any number that falls between, any number that has negative, that has 0, or that is 0, or that is a positive number, are all integers. What about rational numbers? We said that they are what? Integers and fractions. So they are in form of a over b, okay? Irrational numbers, we said that irrational numbers are numbers that cannot be expressed as real fractions or simple fractions of two integers, okay? Where the denominator is not equal to 0 in decimal form. So they are non-terminating, they can never end, and they are non-repeating. So they will never establish a repeating pattern. So it has no simple fraction, infinite decimal, they are non-repeating, and they are not a perfect square. Simple fraction, okay? Their decimals go to infinity, infinite decimals. Their roots are non-perfect squares. So real numbers together with rational numbers, irrational numbers make up the set of real numbers. Okay? So rational numbers and irrational numbers make up the set of what? Real numbers. If you enjoyed this episode about understanding number system properly, kindly click on the subscription button, the notification bell, so that you'll be notified when the next episode drops. We always drop amazing videos on this platform so that you will learn maths from the very basic beginning. We simplify it and you always love it. Thank you for watching.